Hello students, welcome to Young Cubs. Here today I have got for you another session for manipulating algebraic expressions. To understand this video, you will have to first go through the first part of this chapter. Please check my playlist. So today I'm going to teach you how to expand the expressions, the algebraic expressions. So let's start. Children, most important thing is that you need to understand the meaning of the parenthesis. Parenthesis basically means the bracket. The numbers inside the bracket have to be multiplied with the number outside the bracket. So, this 5a has to be multiplied by 2a and this 5a again has to be multiplied by this 1. Let's see how we go about it. So 5 into 2 makes it 10. A into a makes it a square. We have a plus sign in the middle. 5 into 1 makes it 5 and the a follows. Four x into x, that means 4 into 1 makes it 4. X into x makes it x square. Plus 4 into 1 makes it 4 again. X into y, x, y. Two into 3 makes it 6. P into p square. Here we have to apply the rule of indices. This p stands for p1, p raised to 1. So 1 plus 2 makes it 3. So 6p cube minus 2 into 1 makes it 2p cube. Three into 2 makes it 6. C square into d makes it c square d. Remember children, in multiplication, when you are multiplying algebraic expressions, you don't take into consideration the degree or the difference in letter. Everything gets multiplied. 3 into 3 makes it 9, c square e. Half m square into 4m plus 6. So this one is multiplied by 4, which is 4. M square into m makes it m raised to 3. Rule of indices, 2 plus 1, 3 upon 2. If there is no denominator, it stands for 1. So 1 multiplied by 4 and this 2 gets multiplied by this 1. Plus sign in the middle. This 1 gets multiplied by 6. So 6 followed by m square. This 2 multiplies by 1. So upon 2. Children, if you see, the fraction in itself can be reduced to the lowest term. So 2 ones are 2, 2 twos are 4, 2 ones are 2, 2 threes are 6. Sorry. Here it goes. So you have this 2 multiplied by m cube. So 2m cube plus this 3m square, 3m square. Now, since there is an addition sign in the middle, the degree will come into consideration. You cannot add a a variable which has a degree of 3 and a variable which has a degree of 2. So it remains as it is. It does not get added. And that's your answer for this. Alright, now let's move on to the next question. Expand the following expressions and simplify your answer as much as possible. Same technique. Open the brackets. 3 into E makes it 3E. 3 into 5 makes it 15 plus 2E minus 3. Let's bring all the expressions or all the monomials that are the same. So 3E plus 2E plus 15 minus 3. 3E and 2E when added becomes 5E plus 15 and minus 3 makes it plus 12. Let's go to the next one. 2F. 2 into F makes it 2F minus 2 into 4 makes it 2 into 2 makes it 4. Sorry. 3 into F makes it 3F. 3 into minus 1 makes it minus 3. Let's bring all the terms, like terms together. Remember, children, the number will always carry its sign before it. So 3 carries its sign before it. Similarly, this will go as minus 4 and not simply as 4 or plus 4. It goes as minus 3. The sign is always written ahead of the number. So 2F plus 3F is equal to 5F. Whenever there are two minus signs, you add keeping the same sign. So 4 plus, I have kept minus itself. This is minus and this is minus. I'll have minus. But since there are two minus signs, the terms will add up. So 4 plus 3, 7. So 5F minus 7 is your answer. Now, 4F and 2F. 4 into 2 makes it 8. F into F makes it F square. Minus 4 into 3 makes it 12 and followed by F. Plus 5 into 3 makes it 15 and F into F makes it F square. Minus sign in the middle. 5 into 2 makes it 10 followed by F. Let's bring all the like terms together. 8F square plus 15F square. Remember, children, the degree of both is on top is 2. So they are like terms and they come together. Followed by minus 12F. Remember, the number always carries the sign. Minus 10F. 8 plus 15, 23F square. 2 minuses, sign will be minus, but you will add up. 12 plus 10 makes it 22F. Here we go. Minus 2G and H makes it minus 2GH. minus and plus is always a minus. 2 into 4, 8 G minus 3 into H, 3H. Minus and minus becomes plus. 3 into 2 makes it 6, which is equal to 2. So let's find all the like numbers. There are no like numbers. See this. This has GH, but this simply has G. This has minus 3. This has H, but this has no variable. So this remains as the answer. Let's go to the next sum. 5 into 2 makes it 10. H into I, HI plus 5 3s are 15. H minus 7I, minus and minus becomes plus. 7 into 1 makes it 7. Do we have like terms over here? No, we don't. So here we have HI, here we have H separately, here we have I and 7. Children, remember, addition cannot take place if it doesn't have the same variable or the same degree. So that's your answer out here. Three into 4 makes it 12. However, it carries a minus sign. So minus 12J minus out here and plus out here makes it minus. 3 into 3, 9. J into J, J square. Minus 2J plus 14. Do we have any like terms over here? Yes, we do. Minus 9J square minus 12J minus 2J plus 14. So these are the two like terms. Minus 9J square. Both are minus, so I'll put a minus sign. Since both are minus, they will add. So this becomes 14J plus 14. Okay, children. Now let's take a look at how we can solve word problems with relation to algebraic expressions. Write an expression using brackets for the area of the triangle. Children, what is the area of a triangle? Area of a triangle is half into base into perpendicular height. Correct? That's the formula for area. What is the base? This is the base. What is the height? This is your perpendicular height. Alright, so let's substitute. Half into, what's the base? 6a plus 4 into 3a. Alright, children. So, half, I will have to multiply the 3a with 6a and I will have to multiply the 3a with 4 as well, which is 6 into 3 makes it 18, a into a square, plus 4 into 3, 12a. So, can I write this as 18a square plus 12a upon 2. Children, if you see, this 18 and this 12 have something in common, and that is, we could say the number 6. So, can I bring 6 outside? 6 into how much is 18? 3. In fact, children, there is a common as well. So, let me write 6a. So, 6 into 3 and a. So, 6 into 3, 18, and a into a square. Sounds good? I am factorizing it now. Plus 6 into how much gives me 12? 6 into 2, and we already have an a, so we need not add an a inside the bracket because a and a can become a square. So, we just need one a and let that be outside. Let me put the 2. 2 1s are 2, 2 3s are 6. So, 3a into 3a plus 2, that could be your answer, or you can simply open the brackets up. So, 3 into 3 makes it 9a square plus 3 into 2, 6. Either ways can be your answer. Here's a continuity of the previous sum. Okay. So, here we've already given the expression saying that the area is 6a square plus 12a. Write a possible base length and a perpendicular height for the triangle. So, let's write down the area of a triangle again. Area is equal to half into base into perpendicular height. Children, you will have to write down the formula every time you ask to substitute it. So, half into base into height. And what is the area? It says instead of area, we will write 6a square plus 12a. Now, how do you solve this? The 2 goes on the other side. Alright. So, base into height will be 2 into 6 makes it 12a square plus 2 into 12 makes it 24. Let's factorize this. Base into height could also be written as, see, the common number between 12 and 24 is 12. We'll keep it outside the bracket, and inside we can write an a square plus 2. Correct? So, possibly this 12 could be the base and this a square plus 2 could be the height. A possible base and base length and a perpendicular height. Okay? Write another possible base length and perpendicular height for the triangle. So let's take this again. Let's start from here again. So base into height is 12a square plus 24. Thinking of another factor, I can say that 12 and 24 both come in the table of 3 or maybe even 6. So I'll try with 3. So I bring 3 out. Inside 4a square, 3 into 4 makes the 12 and 3 into 8 makes the 24. So possible base could be 3 possible height could be 4a square plus 8. If I do it with 6, I could have 6 on the outside, 2a square plus 4. So, base could be 6 and height could be 2a square plus 4. So, here you go. So, you can have multiple answers for these questions. Come on, let's check the next sum. It says a sequence of 3 squares is shown opposite as in down. The first square has side length of x centimeters. It's a square and it has a side length of x. Okay, so let's remove the area of the first square. It says, so what is the formula for a square? It says side square. So area of a square, I'll just write it in common once. Okay, so let's do area of the first square, which is side square, means x square. So it's going to be x square. Okay, then we have area 2, that means the second square out here, that's going to be 2x the whole square, which is 4x square. I'm going to write it here again. Then the area of the third box, which is this one. So the question says a sequence of 3 squares is shown. The first square has side length of x. Each new square in the sequence has a side length double than that of the previous one. So if 2x is the previous one, the next one will be its double. So it's going to be double of 2 is 4x the whole square, which is going to be 16x square. So here I write down the next one. Okay, then what does your question 4a say? If the sequence is continued, how many squares are there if the total area is given by the expression 341 x square centimeters square? So total area, that means you will have to add this, the area of the first square, second square, third square, and so on. So children, what is the fourth square? Double of the previous one. So if this is 4x square, 4x, if the side length is 4x, the next one will be how much? Tell me. It's going to be 64 plus 4, 8. So double, 4 ka double, 8. So it's going to be 8x the whole square, which says 64x square. I'm going to write it here. See, they want the total area. That means I will have to add up all of these and bring it up to 341. Okay, so then what is the fifth one? Double of 8 is 16x square, which is equal to 256x square. So children, let's find out do all of these add up to 341? 341x square? Yes, they do. Alright, so how many squares are there? So first square, this is the first square, this is the second square, this is the third one, then we had a fourth one and we had a fifth one. So how many squares are there? There are 5 squares. Understood, children? Alright, children, let's look at the B part. The rule for the sequence is changed. The first shape is still a square with a side length of x centimeters. For subsequent shapes, the length is doubled as before, but the height increases by 1 centimeter as shown. So first let's work this out. So the next figure will be the double of the previous one. So double of 4 is 8 centimeter, 8x centimeter, children. It's going to be 8x centimeter. And the height is going to, this height out here is going to be increased by 1 centimeter. So x plus 3 alright. So now write an expression for the total area. Children, total area means first you need to find out the area of all the 4 boxes, all the four figures, and then you need to add up all the areas in the simplified form. So let's bring out the area. Area of first square is going to be x square centimeters square. Area 2 is going to be 2x into x plus 1. Remember, this is no longer a square, it becomes a rectangle, and formula of a rectangle is length into breadth. 2 into x, 2x into x makes it 2x square. 2x plus 1 makes it 2x. So that's what it is. The third one is going to be 4x into x plus 2, which is equal to 4x into x makes it 4x square. 4x into 2 makes it 8x, and this is centimeters square again, this part. And A4, your fourth one, is going to be 8x into x plus 3, which is going to be 8x square plus 24x. So we have to find out the total area now. That means we'll have to add up all the areas. So here we go. X square plus 2x square plus 2, this one, plus 4x square plus 8x, this one, plus 8x square plus 24x, this one. What is our answer? Let's add up all the x squares. X square, x square, x square, x square. So this is 1 plus 2, 3, 3 plus 4, 7, 7 and 8 is 15. 15x square plus, let's add up all the others. 2x plus 8x makes it 10x. 10x plus 24x makes it 34x. That is your expression for this one. Total area. Let's go to the next sum. Two rectangles are shown below. The larger has dimensions 5x plus 1 and 10, while the smaller has dimensions 2x minus 1 centimeter and 10 centimeters as shown. Children, when the dimensions are specified, I prefer that I quickly remove the area. Okay, so the area for the larger one is 5x plus 1 into 10, which is equal to 10 into 5x, 50x plus 10 centimeters square. What is the area of the next one? Area is equal to 10 into 2x minus 1. So it's 20x minus 10 centimeters square. 6 centimeters of the smaller rectangle is placed over the larger rectangle so that only part of the larger rectangle is visible. So 6 centimeter has overlapped this part. Okay, so now what does the sum say? They want the area of this visible part of the larger rectangle. All right. Okay, so let's find this out. We have to find we have to write an expression for the same. So we've already got our area of the larger rectangle, which is 50x plus 10. It's 50x plus 10 centimeters square. Okay, and area of the smaller one is going to be 6 into 2x minus 1. Remember, the length into the width. Okay, it's a rectangle. 6 into 2 is 12x minus 6 centimeters square. So now if we want to find out the area only of the blue part, okay, what do? We subtract the smaller area from the bigger one. So 50x plus 10 subtracted by 12x minus 6, 50x plus 10. This minus sign applies to this 12, so it becomes minus 12x. Minus and minus becomes plus, so plus 6. Let's bring all the like terms together. Which is 50x, 50 minus 12x makes it 38x plus 16 centimeters square. Alright, children. Now, the B part says the position of the smaller rectangle is moved. Write an expression for the smallest possible area of the larger rectangle. So, if this is the larger rectangle, the smaller rectangle completely moves into the larger one. So, what is the area of the larger one, children? 50x plus 10 is equal to 50x plus 10 centimeters square. What is the area of the smaller one now? Remember, we removed it right at the beginning, which is 20x minus 10. It says 20x minus 10. Now we need to find out the area what is visible? Yes, so this part will be visible. We again simply subtract the two. 50x plus 10 minus 20x minus 10, which is equal to, we open up the brackets, minus sign applies to both the terms. So minus and this minus will become plus 10. Bring the like terms together. Which is equal to, this is equal to 30x plus 20 is the area of the shaded term. Hope this video was helpful, children. This is all for today. Thank you so much and God bless all.